Hello all of you. So today we are here with new topic, nucleophilic substitution reaction, which is very important. Okay, in JEE and in NEET and many competitive exams, this mechanism is used to form different type of questions. Okay, so now we'll start. What is the nucleophilic substitution? In very simple words, nucleophilic substitution means nucleophile substitutes something. So what, to whom it substitute? Okay, so in this, when a strong nucleophile substitute another weak nucleophile, okay, the reaction is known as nucleophilic substitution. It is very easy. Substitution which we have studied in the 10th class also. In the same way we'll study this. Okay, that weak nucleophile we call it leaving group because it will be leaving the substrate. Clear? Nucleophile, due to the action of the nucleophile, this leaving group will be leaving and nucleophile will be attached here. Okay, so nucleophile is substituting, that's why it is called as nucleophilic substitution reaction. Clear or not? Mainly this nucleophilic substitution is categorized into two types. Actually there are many types, but mainly here we will study mainly two types. Clear? First type is nucleophilic substitution unimolecular, which is also called nucleophilic substitution first order reaction, which we represent as popularly SN1 reaction. Okay, nucleophilic substitution bimolecular means nucleophilic substitution second order, which we popularly call it SN2 mechanism. Clear or not? Now first of all we'll study about the SN1 mechanism. Actually in both of them, SN1, SN2, the thing is same, the core thing is same, that nucleophile will substitute the leaving group and will take the place of that. Clear or not? You can see here nucleophile will replace the leaving group from its position and will take its place. This is very easy in this way. Clear or not? Okay, now difference is in the mechanism. Clear? Now I'll see the mechanism. See all of you here. So in this step 1, what is the step 1 in this? Let us consider any substrate here, carbon with the leaving group. What is the meaning of these things? These things means that carbon is attached with anything like. Clear? It may be hydrogen, it may be any alkyl group, any group it may be. So in the influence of the nucleophile, it knows that there is a nucleophile. Clear or not? So leaving group will be leaving first. Okay, so leaving group will be leaving as Lg minus, this is leaving group minus, and an intermediate carbocation will be formed. This is carbocation intermediate, which is important thing in this. An intermediate carbocation is formed. Clear? And this carbocation intermediate forming is what? Slow step. Slow step means rate determining step. Rate determining step. So this only step determine everything about this SN1 mechanism. This is the important point in this. Clear? Due to this RDS, this carbocation is being an intermediate. So the reaction stability, the rate of the reaction also depends on the carbocation stability, which we have studied in the previous chapter. Clear or not? In previous video we have explained this. Clear or not? Now on this formed carbocation beta, nucleophile will be attacking and it will be forming what? This desirable product. Any doubt in this? Now in this very remembering thing is that how many number of intermediate? Number of intermediate in this 1, and number of transition state is equal to, you know, number of intermediate plus 1. So number of transition state is equal to what? 2. What is the number of transition state? Breaking of the bond of leaving group from the carbon. Okay, so it will be forming the carbocation. Okay, now nucleophile is going to attack. So the transition state 2 is forming of the bond of the nucleophile with the carbon, and which is the intermediate? This. So one intermediate and 2 transition state. So what will be the energy profile for this mechanism is that, see, let us consider these are the products. Products are starting from it. Okay, so one transition state, then intermediate, and then second transition state. Can you see this? Yes. Let me draw this more efficiently. Okay, I am showing here that products are more stable, so I am showing here the less energy product. These are the reactant, this is the product. Clear? This is transition state 1, this is transition state 2, and this is what? Intermediate. Okay, so this is the energy profile for the SN1 mechanism. Clear? Again I am repeating, formation of the carbocation, leaving of the leaving group. In this, the main thing is also that leaving group will be leaving before attacking the nucleophile. I have written all these things in words, okay, by following. Okay, so in this leaving group will be leaving the substrate before attacking the nucleophile. Carbocation will be formed, and on that carbocation nucleophile will be attacking, and this attacking is the fast mechanism. Clear or not? Now in this one thing you can see, this is the RDS. So rate of the reaction will be determined by this step only. So rate of the reaction directly proportional to the substrate only, that is RLG. That's it. Okay, and you can see that its stoichiometry is 1, so to the power 1. Okay, that's why order of reaction is equal to 1. That's why it is called as unimolecular or first order mechanism. Clear or not? Okay beta, so this is first order mechanism, SN1 reaction. Any doubt in this? Okay, now in this some important points which we will see. Okay, that I have already mentioned, I already explained in this. In SN1 mechanism, bond begins to break before the nucleophile attacks. Yes, leaving group will be leaving before attacks of the nucleophile. Carbocation is formed as intermediate, so rearrangement is possible, and 2 degree and 3 degree alkyl halide show SN1. Why? Because in the previous video we have seen that 3 degree is most stable, 2 degree then less, and the 1 degree and the methyl are least stable. With higher SN1, with higher due to higher stability of the 2 degree and 3 degree carbocation. Clear or not? Okay, so we can say that, as I said in the mechanism also, that leaving group tendency. See in this, if leaving group is not ready to leave the substrate, how the mechanism will take place, how the reaction will take place. Clear or not? So for this, leaving group must be leave the substrate very easily. Clear? So leaving group tendency. So we should have a good leaving group for the nucleophilic substitution reaction. Now in this, the intermediate is formed. What intermediate? Carbocation intermediate is formed. So the stability of the carbocation is necessary. Clear? Steric crowding. Much steric crowding, much stability of the carbocation. Clear or not? That's why example is here in this. This is 3 degree halide. This is 2 degree halide. This is 1 degree halide. You can see, and this is, we have the methyl. Okay, in this now you can see when leaving group here is what? Cl. When it will be leaving the substrate, what beta it will form? You can see here, it will be leaving the substrate, what it will form? See, in this it will be forming this 3 degree carbocation, this 2 degree carbocation, this 1 degree carbocation. Clear or not? Okay, now in this what will happen? You can see this 3 degree carbocation is most stable. Okay, so 3 degree alkyl halide, that was what? Cl, will show this reaction with higher rate. Is it clear or not? Okay, so this is the SN1 mechanism. Now the next thing in this, the carbocation is formed. So nucleophile has equal probability to attack from the top and bottom of the vacant orbital. You know that carbocation is having sp2 hybridization and one vacant orbital. You can see this vacant orbital after leaving the leaving group. Cl is being left from here. Okay, so nucleophile has the tendency to attack from either side. Clear or not? It has the tendency to attack from the either side. So two products will be formed, two possible products will be formed, and those possible products I am drawing here. You can see CH3, this is pH, this is nucleophile, and one more product CH3. Just a minute. Okay, this is what we have, the pH. From here it is ethyl, and this is nucleophile. You can see here, you can notice one thing, that these are nothing but what? Mirror images of each other. So in SN1 mechanism, if it is chiral center, then in SN1 mechanism we get the racemic mixture. What we get? Racemic mixture. Clear beta? Any doubt in this? So this is complete SN1 mechanism. Okay, now we are coming to the SN2 mechanism. Same thing, nucleophile substitute the leaving group. Okay, in this the only thing which happens is that leaving group, the Cl, this is the leaving group. Let me write it, leaving group. Leaving group is not leaving the substrate before attacking the nucleophile. In this, nucleophile attacks from the behind. Okay, it will be leaving, it will be in this way. This is D, this is H. Okay, and this leaving group will be leaving. Now in this you can see what? You can see here very easily that nucleophile is attacking here. Okay, and leaving group is leaving. Okay, I can draw this in this way also. In stereochemistry, if I want to draw this, then it will be what? This is T. Inversion of the groups will take place, and this is the intermediate. This is what? Intermediate. This is a pentavalent intermediate. Can you see this? 1, 2, 3, 4, 5. Pentavalent intermediate, and its hybridization is sp2. Why sp2? Because the main bonds are in this one, 3 bonds. Okay, 3 sigma bonds. That's why its hybridization is sp2. And the product, we got the inverted product. This thing is important in this. Clear beta? This thing is important in this. Okay, you can see here the deuterium was at the dash position. Here it is wedge position. Tritium was at the wedge position. Here it is at the dash position. So this complete inversion takes place, which we call it Walden inversion. This is the main thing in this. Walden inversion takes place in this. Clear or not? And this reaction is slow step mechanism. This is RDS. Clear or not? Any doubt in this? Okay, now in this you can see this is the slow step. Nucleophile attacking the substrate. This is the slow step. So in this is only the rate determining step, and rate directly proportional to the Nu minus and RLG. So 1, 1. So order is equal to 1 plus 1. It is 2. That's why it is second order reaction. And one more thing in this. This is actually not intermediate. This is only what beta? This is transition state. I should write it. This is transition state. In this, no any intermediate is formed. This is the only transition state, no intermediate. So if only one transition state, no any intermediate. So what will be the energy profile? In this, the energy profile will be what? Only single peak in the graph. That's it. Only single peak in the graph. This is the reactant, this is the product, and this is the transition state. Clear or not? Okay. Now in this, one more thing. See, nucleophile is attacking from the behind. So the crowding on the carbon should be less. If crowding on the carbon would be higher, then nucleophile will not be able to attack on this carbon. Clear or not? So for the SN2 mechanism, the crowding on this carbon of leaving group should be less. Means oppositely of the SN1, SN2 reaction will be higher in the 1 degree and least will be in the 3 degree. Clear or not? So this is complete SN2 mechanism. Okay, I have written some point here which are same as I explained, so you can note down from here also. Okay, so this is the nucleophilic substitution mechanism reaction. Thank you to